Welcome, friends. This video is in a series of regression analysis using SPSS, and this part we are going to cover the moderation analysis. So those who have not seen the correlation or the part 1 and part 2 of the regression analysis, they are advised to see them first and then come to this. So friends, we know how to get this kind of regression analysis output. Okay, and we check whether the age, performance, stay, and TC influences the salary or not. And we see this age beta coefficient is significant. Performance score beta coefficient T significance value is just 0.05 as it 0.051. Stay years is less than 0.05 and TC is less than 0.05. Okay, so with that we can say that that age, performance score, TC does affect the salary. Sorry, age, stay, and TC. Performance score can be debated. Okay, can be debated because the significance value is only 0.051. So this is what we get from the regression analysis. But now, once we establish a relationship between independent and dependent variable, we want to confirm or we want to check whether this relationship is impacted by something else or not. And that's we call it a moderation analysis. That means, for example, does gender influences the relationship between age and salary? Diagrammatically, in your research framework, it may be something like this. That we have the age as an independent variable affecting the salary. Affecting the salary. And this relationship getting impacted by the gender. This one. And similarly for the performance to salary, stay to salary, and TC to salary. So let's see how to do that. So what we will do, we will do the regression analysis with a two set of data. So we have a total, let's say 268 observation after the cleanup. We have to bifurcate this. The respondents who are male and the respondents who are female, and do the regression. So this is the output of around 142 observations, which are for the respondent who are male employees, and this is for the female employees. So first we'll check. So in the moderation analysis, first we'll check whether the outputs are significant or not. Here, in case of a male, the output is significant. F significance is there. In case of a female also, it is there. So first point is clear. The second point, the R-square value. The R-square value in case of a male is 0.852. In case of a female is 0.784. You have to find out the difference between these two. In this case, the difference is going to be, I think, 0.09 or something, or whatever value. So you have to check whether the difference of R-square value is less than 0.13. If so, we say there is a low moderating effect. If the difference of R-square value is between 0.13 to 0.26, we say it's a medium moderating effect. And if the difference of the R-square value between these two is more than 0.26, we say it's a very high moderating effect. Okay. So in this case, it's very low moderating effect. So moderating effect is there. Now we want to confirm from where it is coming. So let's now see the third part. That's a individual parameter. So we'll start with the age. Is the age significant in the case of a male? No, it is not. In case of a female, yes, it is not. So in both the cases, the age is not a significant parameter. Both are same. So no moderating effect onto the relationship between age and salary. Next one. Is the performance score significant? Yes. Is it significant here? Yes. So if both are not significant, we stop there for that variable. If both are significant, now we go for the next step. This is significant. Performance score is significant in case of a male. The performance score is significant in case of a female also. Now let's check the beta coefficient value. Here it is -62. Here it is -142. In both the cases, it's negative. But in case of a female, the negative value is larger. That means the effect of performance score on salary in case of female is higher as compared to male. In case of a male, the performance score does reduces the salary, let's say by 62 unit. In case of female, it reduces by -142 unit per percentage increase in the performance score. So we can say yes, the gender does moderate the relationship between performance and salary. In case of a female, the reduction in the salary is higher as compared to the male. This is the statement you are going to make. Third one, stay years. Stay years significant in case of a male. Stay years is significant in case of a female as well. Both are significant. So we'll check the beta coefficient. It's 5757. It's 5402. So in case of a male, per unit or per year rise in stay with the company, increase of the male employee salary by 5,757. In case of female, the increase is 5,400. So there's a difference of 300 rupees. We can say the moderate effect is there. In case of a male, the impact of stay years onto the salary is higher as compared to female. The last one, TC, is not significant in case of a male. It is also not significant in case of female. So there is no moderate effect. So to conclude here, the gender does not moderate the relationship between age and salary. Both were insignificant. Gender does moderate the relationship between performance and salary. In case of female, the impact is higher. Gender does moderate the relationship between stay and salary. In case of a male, the impact is higher. And the gender does not moderate the relationship between TC and salary. So here we did this way by putting two separate outputs because my moderating variable was categorical variable. Now imagine if your moderating variable is a non-categorical variable, then what you will do? One more thing, in case of here, we have to check the influence. So we find that the highest influencing parameter was stay years. In both the cases, it's same. So if it's a change, we have to report that as well. Okay. Suppose your moderating variable is not a categorical variable. Okay, it's a binary variable, like technical training given or not. The method remains same. We will first do the output of for all employees who have been given technical training. Sorry, who are not given technical training, and similarly, who have been given a technical training. And then you compare, like again, both our regression outputs are significant. The Oscar value is here 0.820 and 0.879. See the difference, low moderating effect. From where the moderating effect is coming. For example, here age is significant. Age is also significant. Here's minus 121, it's minus 88. So moderating effect is there because the beta coefficients are different. Performance score in case of a male is not significant. That means performance score in case of the employees who have not given a technical training, it is not significant. In case of employees who have been given a training, it is significant. That means wherever the technical training is given, the performance score does influence the salary. So that's a moderating effect. In case of stay years, both are significant and the beta coefficient is 5,700 and 6155. So a low effect is there. And in case of a TC, the people who have been given technical training, the TC is a significant parameter. But in case of employees who are not given technical training, it is not significant parameter. So that's a moderating effect. That wherever the technical training is given, the TC does influence. And in other cases, it does not influence. So here, we can say that the technical training does moderate the relationship between age and salary. In case of people who are not given a technical training, the reduction is higher. The technical training does moderate the relationship between performance and salary. In case of people who have been given technical training, it is significant. In other cases, it is not. Same way with the TC. And the technical training does moderate the relationship between stay and salary. In case of people who have been given a technical training, the impact is higher on the positive side. So in this case, all the four hypotheses are supported. We can check similar thing for the competency training. Now, if your moderating variable is a numeric variable, we saw the first case, gender, categorical variable. Second case, technical training given, not given, binary variable. Now it's a numeric variable. In that case, we can't have a category for each value of the numerical variable of the moderating. So what we do, we go for the interaction effect. And for that, we have to convert all the variables into a standardized variable, which are being used in the regression analysis. So go to analyze descriptive statistics descriptive. Since we are checking three variables, age, stay, and salary. So age, stay, and salary you pick up here and tick this checkbox. Save standardized value as variable. You click on OK. Once you do this, you will get three additional columns, each one for stay, salary, and age respectively. They are standardized value. Okay, using that formula z0 to x minus mu upon sigma. Once you have that, now we need the interaction effect or interaction column of moderating variable and independent variable. In this case, age and stay. So you'll go to the transform compute variables and compute the interaction column called age into stay, z age into z stay. Now, friends, since we wanted to multiply them together, we convert them to a standardized value. Otherwise, since both variables are of, if they are of different scale, to multiply that, then the whichever variable have a higher values, that will dominate. So to remove this, we bring both the variables on the same platform, same average value and same standard deviation, and that's how we standardize them. So now we multiply that. You have to pay attention that this column will have a values positive and negative. This column will have both value positive only when the age is positive and stay is positive, or the age is negative and stay is negative. Now you have to think why, when the z age is positive means what? These values are above average. So we say that the interaction column will have a positive value when both the column either are above average or below average. That means they go hand in hand. In those situations, the values will be positive. If the age is, for a particular employee, age is above average and the stay years is below average, that means they are going in opposite direction. That the interaction column will have a negative value. Okay, so keep this thing in mind. So when we interpret the output, this understanding will be required. So when you compute, you have one more column called interaction column. Now, with this, go ahead and compute the regression. First, you will do the regression with a simple linear regression of stay with the salary. Note down the Oscar value and the coefficients. Now, this coefficient are the standardized value coefficient. Okay. So, this regression are using the standardized value of the variables. In the second regression, your dependent variable is going to be salary, and in your independent variable box, put stay, age, and interaction column. Stay into age all together. 3. Okay. Don't do 3 separate regression. It's all 3 together is the independent variable. And for that, report the R-square value and the corresponding beta coefficient. Now, first step, check the difference of R-square value. So difference of R-square value here is very, very small. It's only 0.003. The first is to check the difference of R-square value. So we can say that there is not much difference, it's very, very small. So there may not be any moderating effect. Let's confirm this. To confirm this, you have to check the p-value of the interaction variable. The interaction variable was stay into age, z value. And the p-value is 0.649. Is this less than 0.05? No. Since the value is not less than 0.05, we say the moderating effect is not there. Moderating effect of age onto the relationship between stay and salary is not there. If it is less than 0.05, then check the sign of the beta coefficient. If the sign of the beta coefficient is same as the sign of the independent variable beta coefficient, I repeat, compare the sign of independent variable beta coefficient and the interaction variable beta coefficient. Both are same. We say the moderating effect is amplifying the effect. If they are opposite, it's weakening, it's dampening. We'll see in second example this as well. Okay. So there are 4 steps. First, compare the R-square value. Second, check the p-value for the interaction variable, interaction column. If the p-value is significant, that is less than 0.05, then third, check the same sign. If the sign are same, that means the independent variable beta coefficient and the interaction column beta coefficient. If they're same, we say the moderating variable is amplifying the effect of independent variable onto the dependent variable. If the sign are opposite, we say the moderating variable is weakening or dampening the effect of independent variable onto the dependent variable. In this case, we say the age does not moderate the relationship between stay and salary. So look at here. You have this coefficients. What you can do for stay, take value -1 +1. And for age, again -1 +1. That means below average, above average. So you have 4 scenarios. Age +1 -1 and stay +1 -1. So 4 combinations. And with those 4 combinations, predict the salary. So you get these 4 data points. 1, 2, 3, and 4 and make a graph, okay, between the value of independent variable and the value of the dependent variable. So when the value of the independent variable increases from low to high, what happens? When the moderating variable is low, that is blue color, the slope is this. And when the moderating variable is high, the slope is shown by the slope can be inferred from this golden color line. You can see both the slopes are same. Why? Because the moderating variable has no impact. Okay. Let's see this similar thing in the next example. We want to check the moderating effect of TC onto the stay and salary. And for that, we first converted TC, stay, and salary as a standardized variable. Then we computed TC into stay as an interaction variable, interaction column. And then we conducted first regression simple linear with stay on salary only. We had R square and the beta coefficients. Now conduct the regression analysis with the salary as a dependent variable, stay, TC, and interaction variable column as a independent variable. We see the R square value difference is there somewhat. Okay, the R square value difference is 0.014. Okay, and so it is there. The small moderating effect is there, but most importantly, the p-value for the interaction column is less than 0.05. That means the interaction column is significant. Since it is significant, we can say that the TC does moderate the relationship between stay and salary. How? Check the value of the sign of the coefficient. This is positive. This is also positive. So independent variable beta coefficient is positive, and the interaction column beta coefficient is also positive. Since both signs are same, we say the TC amplifies the effect of stay onto the salary. Let's try to visualize what is amplifying means. Again, take two values of the stay, plus and minus 1. So -1 and +1, low and high. Similarly, two values for TC, -1 and +1. See this blue color line. This shows the slope when the moderating variable is low. When the moderating variable increases from low to high, what happens to the slope? You see the slope has changed. The slope has increased. That means the effect has amplified. Now, in case when the moderating variable is high, the effect of independent variable onto the dependent variable is increasing as a higher rate. The slope is higher. That's what we call the amplifying effect. Okay. So we checked the three scenarios of moderating effect. The first scenario, when the moderating variable is categorical variable like gender, you put two regression output, compare them. You compare based on the F significance, R square value, T significance, beta coefficients, and standardized beta coefficients. Second scenario, when the moderating variable is binary, 0, 1. Same method, like the categorical variable, two regression output, compare them onto these parameters. If your moderating variable is a numerical variable, we have to convert the moderating variable, dependent variable, independent variable into standardized variable. Then put a two regression equation, find out two R square value, compare them, check whether the beta coefficient for the interaction column is significant or not. If it is significant, then only we'll conclude that the moderating effect is there. If the sign of the beta coefficient of independent variable and the interaction column with beta coefficient is same, we say the moderating effect is amplifying. It's amplifying moderating effect. If the sign are opposite, we say it's a weakening. That's all, friends. Thank you very much.